Computer Programming for Kids, Step 17. Make sure and just in case, or throwing, catching, and teasing of future logging. You might remember from Step 16 that a subset of the code we discussed looks like this. And it shows a try-catch block of code in the newsletter. So what is this try and catch all about? What is its raison d'etre, as the French say, which apparently means something like raisins to eat? Don't ask me why. We will discuss in this step not only the importance and value of the try-catch structure, but also the related try-finally structure. First, what is meant by try? In a nutshell, when you use a try block, you are saying, try this code. I hope it works. At any rate, I'm adding either a finally block to deallocate any resources that were allocated so that they're not hanging out there in space like a lost balloon, and or a catch block in case there's an error. Note, we will talk about what allocating and deallocating resources means later. For now, just think of it as putting away any toys you got out in the try block, putting them back where they belong in the finally block. Some future code samples will incorporate finally blocks so you can see exactly how they are used. You can have both a finally block and a catch block within a single try block, like so. And then the newsletter shows a try section, then a catch section, then finally a finally section. Without any real code in it, just showing those structures. If there is a problem within the try part of the code at runtime, first the catch block of code will run, if it exists, and then the finally block of code will run, if it exists. You can leave either one out, but not both. That is to say, if you have a try block, you have to have at least one or the other, if not both, a catch block and a finally block. We talked a little bit about the finally block. Now, what is meant by the catch block? What is it that is being caught? A fish? No. A cold? No. A fly ball hit into the outfield? Again, no. Unfortunately. As you can see in the rest of that line, exceptions are what we are dealing with. And it shows a line of code that says catch, and then within parentheses, exception, EX. So an exception is being captured and examined. Exception is an object. The name we have given it is X, EX, which is the customary name, standard programming practice, at least with C#. We could actually name the exception object pretty much whatever we want, but going with the standard naming convention is best here. So what is an exception, and now that we have caught it, what are we going to do with it? Before we go there, let's talk about how this structure works and why the name of the object is exception. The code within the catch block only runs if there is an exception. Naming the object that shows that it is something that is not expected to happen often. It's something that is exceptional. Not in the sense of, wow, that painting is exceptional. You have natural talent. But rather in the sense of, that's weird. I wasn't expecting that to happen. There's good news and bad news about this. To get the negative stuff out of the way first, the bad news is that if the catch part of the code runs, it means our code has caused an error. Or maybe not caused an error exactly, but it is reacting to an error that has occurred somehow. Even if our code didn't cause the error, it also did not prevent the error from happening. Have you ever heard the admonition, if you're not the solution, you're part of the problem? That can apply here. When that happens, an error or exception occurs for whatever reason, The execution of the code jumps from whatever line caused or encountered the error directly to the catch block and runs the cleanup code that we put there. In the example above, what we do within the catch block is this. And it shows a couple of lines of code. Messagebox.show, and in parentheses, ex.message, and then throw. What does that do, you ask? The first line displays to the user of the app, us that is, the message property of the exception object. That is to say, in common parlance, that it displays the error message. So we at least get some idea of what went wrong, hopefully. The second line re-raises the exception. Both lines need a little more explanation, I take it. Having the error message display in a message box will leave the verbiage of what went wrong up on the screen until you close the dialog box, called message box here. By the error message staying on the screen until you get rid of it, or dismiss the dialog box, it allows you an opportunity to take a screenshot of it by pressing the PRTSC key on your keyboard and then pasting it into some app like Paint. Alternatively, you can write down the error message on a pad of paper or on your skin somewhere, giving yourself an interesting temporary tattoo. Once you have the error message recorded in pixels or ink, you have basically 4 options. Well, 5, but the 5th option, just giving up, is not really worth considering. So we won't enumerate it here. And for now, I'd advise sticking to just the first 2 options, as we'll go over the other options in more detail in future steps. 1. Give the code wherein the error occurred a close visual inspection after shutting down the app to see if the cause of the error is obvious, based on the error message. Note, examining your code by running it in your head as you look through it, with a frown on your face due to intense concentration rather than consternation, and your chin in your hand is called desk checking in programming parlance. 2. Do an internet search using just the text of the error message, copied from the screenshot or your flash, or perhaps adding C# to it. For example, if the error message is, "You zigged when you should have zagged," your internet search may be C#, "You zigged when you should have zagged," or even C# Visual Studio, "You zigged when you should have zagged." You might find an answer among the hits that help you solve the problem. Note, a good thing about errors or exceptions is that they add to your storehouse of knowledge of what to avoid in the future. In other words, we learn from our mistakes. The only way to avoid mistakes entirely is to never do anything. Making mistakes doesn't mean you're dumb, it just shows you've been busy. As an example of what may cause an error, sometimes the problem stems from trying to access an object that doesn't exist yet or anymore. We'll talk more about that later. The point is, every exception can be a lesson learned that makes you a better programmer. But don't get discouraged if you make the same mistake more than once or even more than a dozen times, or a baker's dozen. You'll eventually get it, if you keep at it. 3. Step through the code a line at a time at runtime to see exactly where the problem occurs. I do realize that you probably don't know what that means yet. I will show you precisely how to do that in a future step. There's a fair amount to it and quite a bit to discuss, but I think you'll find it interesting and very enlightening, as you can see exactly what's happening with your variables as you move through the code. 4. The 4th option is to add logging code to your app that can save more detailed information about the exception and other things that happen in your code. You save this log to a text file that you can later examine at your leisure. Going over the traces or footprints that your code left behind is sort of a post-mortem of your code. you're playing detective. We'll also leave logging for a future step. Another option, besides the just giving up option, which I hope is not an option, is to ask a question on a programming question and answer site such as Stack Overflow. But I would recommend against that for now. You might want to hold off on going that route until we discuss it, too, in, you guessed it, a future step. You might think of going this route as soon as a sort of the nuclear option, to be used only in case of emergencies. You'll see why when we discuss it in more detail later. Now back to the second line in the catch block, namely, throw, semicolon. What is being thrown? A frisbee? A tantrum? A party? No, no, and no. What is being thrown is the exception. Why? When an exception being thrown is what is causing this code to be reached in the first place. It's because by adding a catch block to your code, you are in a sense saying, okay, I've got this. Don't worry about the exception. I'm going to take care of it myself. Which is kind of dangerous since you don't know in advance exactly what sort of exception is being thrown. Thus, don't know how to deal with it. It's best to let the compiler handle the aftermath as best as it can. That's what calling throw does here. It re-raises the exception, gives it back to the compiler to handle after you do whatever you want to do prior to that, such as showing the message box with the exception message in it. So to reiterate, what the code is saying is this: catch exception X. If an exception occurs, I'll handle it. Messagebox.show with x.message passed to it. Here's the exception's explanation of what went wrong. Throw. Hey, compiler, you can have responsibility for handling the exception back again. I'm throwing it back to you. I was just teasing that I was going to take responsibility for it. Gotcha. At a minimum, the example shown is what you'll want in your catch block, showing the error message and re-raising the exception. You can use it in any code you write, and the more complicated the code is, the more likely it will actually come in handy. The finally block is less often necessary. You only need it when you are allocating resources that may get left in the hallway for someone to trip on if they are not cleaned up or freed in programming terms. To sum up, both the try-catch and the try-finally blocks are very handy structures to use in your coding. As mentioned above, we will later learn about stepping through code as an essential part of debugging, and about logging, a topic closely related to the one in this step. Of course, the logging we're talking about here is not the type that Paul Bunyan and his Blue Ox Bay were famous for. It's a different sort of logging altogether. Until then, earth-shakingly important notice: if you have a basic programming question suitable to an audience of kids, send it to idiolectable@gmail.com, specifying whether you would like your name and location used if it is printed in a future step of this newsletter. If you are a subscriber to the newsletter, you can also leave a question at the bottom of this step in the comments section. If you do not want to give your real name, a nickname is acceptable. The first letter to the editor of mine that was printed appeared in Rolling Stone magazine back in the early 1970s, and I signed it Sylvester for some reason which I no longer remember. Finally, it's always interesting to see where people are from, so please provide your city or town and the state it's in too, or province, or whatever the region where you live is called.